Let's get started, and we're going to review Module 8, all about SLAAC and DHCP version 6. So this is setting dynamic addressing for IPv6. If you notice, there's a bunch of different ways for IPv6 addresses to get assigned. It isn't like IPv4, right? With IPv4, you can either just manually assign it, or you can have a DHCP server assign it, right? The other way is there isn't a PIPA address, right? So an PIPA address is something that gets assigned if there's no DHCP server, right? So how can I tell if there's been an PIPA address assigned and no DHCP server when it comes to IPv4? Let's start with that simple question.
Hey, Andrea, this is for the interpreters. Would you mind spelling that acronym for us?
Yeah, it's APIPA, a PIPA, and I'll put it in the chat box too.
Thank you.
How do I know that I have it for DHCP version 4, just plain old IPv4? What is an PIPA address and how do I know it? Yeah, it's going to start with a 169. Right? So if you do an IP config on your computer and you have a 169 address, well, what you can tell is that your device is not talking to a DHCP server. Okay? Now there's something like that with DHCP version 6 as well. It's called a link local address, where your host will assign and get its own link local address. So it does something similar, because remember, what do these devices always want to do? What are they always trying to do all the time? Yeah, they're always trying to talk to each other, right? They're always trying to gossip. They're always trying to talk to each other, right? They're either talking to each other or talking to switches, or switches are talking to other switches, and switches are talking to routers, and routers are talking to other routers, right? The whole point of networking is for them to all converge and all be talking to each other, right? All right, so with IPv6, right, how many different ways can I assign an IPv6 address? Okay, there's several different ways. Okay, I can statically assign it, so that would be one. Dynamically, okay? I can assign it statically or manually, right? And then I can do it dynamically, Chris. And then there's a few different ways to do it dynamically. So how many different ways are there to do it dynamically? Yeah, there's 3 ways. So Chris, you're right, and SLAAC is one of them. Okay, so I can statically assign an address, right? I can statically assign it. The other way is I can use something called stateless or SLAAC. Okay, so, and there's 2 different ways of doing that. One is called SLAAC or SLAAC only. The other dynamic way is to combine SLAAC with DHCP. So if I combine the 2, okay, and then lastly, I could just straight up use a DHCP server for just straight up dynamic assignment. So there's a total of 4 different ways that I can set up my network with IPv6. Okay, so if we look at that, so this is something we've seen before, right? So we know how to go into our control panel, and notice here we've set assign statically, or yeah, assign statically, because we're not doing the automatic. So right here is what our static assigned address is. So that means me as the network administrator or the person sitting at the device has assigned it statically. Now what does this mean right here where it says subnet prefix length 64? So right here. Yeah, exactly, Michael, 64 network bits. Now it actually, we know for a fact that it isn't using the EUI64 process because I'm statically assigning this address. The EUI64 process only plays into DHCP version 6 with one of these methods, stateless SLAAC or SLAAC with DHCP server. Otherwise, the EUI64 process isn't involved at all. So this 64 is referring to the first 64 bits of the 128-bit IPv6 address. Now, the second 64 bits are what in an IPv6 address? It's the globally unique address, okay? So with an IPv6 address, we have the network portion, and then we have the unique portion that makes it unique to every host device. Okay, so that's static. Now, the other option is SLAAC only, or SLAAC plus DHCP. These are both dynamic. They're ways to dynamically assign my host devices down here with an IPv6 address. I realize that this has IPv4, but just think of it in terms of that we're going to be setting up DHCP version 6 for IPv6 assignment. Okay, so if I'm doing SLAAC only, then what that means is I'm using the router instead of a DHCP server. Okay, if I'm using SLAAC plus DHCP server, that means I'm hosting some of my DHCP information on my router, and I'm hosting the rest of my DHCP information on some sort of a server, either a DHCP server or a file server that contains DHCP information. Now remember, both of these are dynamic, okay? They're both dynamic. Or lastly, the fourth way of assigning an IPv6 address to a client is just straight up using a DHCP server. So that means I'm not using a router to store any of the DHCP information. I'm going to use just a straight up DHCP server for everything. Okay, so let's just review this IPv6 addressing again. So if you remember, an IPv6 address has 128 bits in it. We delineate everything with hexadecimal, right? So each one of these values is how many bits? How many bits is each nibble? So that right there represents how many bits?
128, right?
Well, the whole address is 128 bits. But this one position, this one hex position represents 4 bits. Exactly. So each one of these is called a nibble. That's exactly right. Each one of these is called a nibble. Okay. So if this is worth 4, and this is worth 4, and this is 4, and this is 4, then how many bits is represented in a hextet? And I see Maria has 16, right? So 16 and 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 16, that's 128. So
just a quick clarification, Andrea.
Yeah.
So does a nibble always equal 4 bits?
Always, yep. So a nibble will always equal 4 bits. You have 4 nibbles per hextet for a total of 16 bits per hextet. This IPv6 address is 3 different sections. So what is the first section and which hextets are part of the first section? Yeah, exactly right, Maria. And what is that called? Yeah, so that's the site prefix. And it's who assigns the site prefix. That's more than, I want you to use the term network, right? Yes, the ISP. The ISP assigns that. And then what's the next part of this IPv6 address? Again, I'm just going to tell you guys, if you don't know this, you need to start reviewing your 140 notes, okay?
The host?
Nope, it's the subnet ID, right? The next portion of the IPv6 address is the subnet ID. Then the last part is the host, right? So there's where our host is. Yes, and that's our interface, our unique interface. So this is the network. It's assigned by the ISP. This is the subnetting portion. I, as the network administrator, will use that to basically break down my buildings, my offices, and then lastly, the unique host address. I'm just going to remind you, if you don't know this IPv6 stuff, you want to review it. You want to know how to do compression of IPv6 addressing, decompression, how to eliminate zeros, when to use colons. You need to know all of that. So it's important to understand these addresses for when we are going to do IPv6 DHCP, because we make use of a lot of this stuff, right? So it's important that you know what each of these are. Routers will communicate to clients in order to tell them which method they're going to have to use to get an address, okay? Because when a host device turns on, what's one of the first things it tries to do? It wants a what? It wants an IP address, right? And if it's an IPv6 network, it wants an IPv6 network address. It wants an IPv6 address. The routers are going to communicate to the clients in order to tell them which method they're going to use. Are they going to use a DHCP server? Are they going to use stateless? Are they going to use a hybrid of stateless plus stateful? Right? They're communicating. So what type of a message is the router using to communicate this information? And I did see the answer in the chat box. Yeah, it's using a router advertisement. And then I also saw up here an ICMPv6. So exactly, it uses an ICMPv6, so kind of like a ping packet, okay? Router advertisement. So it uses this message to communicate to the client, oh, hey, I just got your message, thanks. And this is how we assign IPv6 addresses on this network, right? It's talking to the client and it's telling it which of the four, really which of the three ways, because if it was statically assigned, we would go in there and statically assign it. So communicating with the client. What does the RA message contain inside of it that is used by the client to know whether it will be using a router configured DHCP or if it will be using an actual server or if it's going to use a combination? What's inside of the RA message? Flags, exactly right. There's flags inside of the message, and these flags are used to communicate with the devices. So there are three flags. I'm going to talk mostly about the O and the M flag, okay? But yeah, there's three flags in there, okay? So there's going to be a managed address configuration flag and an other flag, okay? So we're going to talk mostly about the M and the O flag. I forgot about that A flag. So it's super important that you understand what the M and the O flags mean. Okay, M flag is always, so again, it's super important that you understand what these different flags do. So the M flag is always going to be referring to a DHCP server and the management of IP address. Okay, so your M flag is always referring to the DHCP server assigning addresses, always. So if you think of it kind of like the DHCP is managing address assignment. So here we have this DHCP server. So if I'm using a DHCP server, the DHCP server is giving out the addresses. That means the M flag is going to be on. Now in computer language, how do we represent on and off? Ones and zeros. Yep. So a 1 would mean it's on, and a 0 would mean it's off. Do you agree with that? So if my DHCP server is managing my IP address assignment, will my M flag be on or will my M flag be off? On, right, Dom? It'll be on, okay? Then our O flag refers to other devices, right? That we have other devices and that the other devices are being used for something. They're storing DNS information, they might be storing default gateway information. There's other things too that we haven't actually talked about that could be stored on there too, but primarily it's going to be like your subnet mask, your prefix length, or it might be your DNS server, so other. So we manipulate these flags depending upon which version of DHCP6 assignment we're doing. So in our network, if we are using another device, a different device to gather information, right, or to give information to the client, then the O flag would be turned on. So I manipulate these flags to tell the client where and how it's supposed to get its information. So I'm manipulating those flags. Now you might ask yourself, well, where are these flags? Well, where else would they be but in the header? So they're going to be in the IPv6 header. So if you look right down here, we've got the managed address configuration flag and the other stateful configuration flag. The device can de-encapsulate that and look inside, and it can assess, oh, well, the managed flag is off and the other flag is off. That means I'm using SLAAC. So the client can make some decisions based on the advertisements that it receives from the router. So the M flag is the actual DHCP server. So we're going to cover that command as we move through here. So this is why I'm saying don't worry about it. Taking notes will help you, because keeping SLAAC and SLAAC plus DHCP and DHCP, keeping them all straight, until you really kind of get it, it's easier if you write it down, okay? And I know that as you read the module, it's not like it just falls into place so easily, okay? So a stateless, if we're doing stateless DHCP, what that means is that I am using my Cisco router as a server, because we know our Cisco routers are robust, they have lots of capabilities. Well, one of their capabilities is to behave like a DHCP server, okay? Now, if I'm using SLAAC only, then that means I am not going to be using a DHCP server for anything. Me as the network administrator, when I'm setting up the configurations, I'm going to give the router everything it needs. I'm going to give the router its prefix length so that it can tell the clients. I'm going to tell the router what the DNS server is so it can tell the clients. I'm going to tell the router what the network address is. Like, as the network administrator, I configure everything into that device so that it can function as a full server and do all of the work that a DHCP server would normally do, okay? So if we have this computer that comes online, the first thing it does is it starts talking because it wants to get an IPv6 address. So notice what it gets back from the router, right? It's like, hey, I received an RA message, so it's received a router advertisement, and the router advertisement is telling me that I'm going to get all of my information, my address, my network information, my DNS server, everything from the DHCPv6 configured router. So the M flag is off, right? Because if the M flag was on, that means I'd be getting my IPv6 address from a DHCP server, an actual physical server. But it's off. And the O flag is off. So that means I also don't need to get information from any other source. Everything's coming from the router. My router is serving as a fully functional DHCP version 6 server. Okay, so my M flag is off and my O flag is off. So when a router is used to assign the DHCPv6 addresses, the DHCPv6 router uses the RA message to deliver all of the required information. So again, you can see that this router advertisement has a lot of functions. It does a lot of things. If you compare it kind of to like a hello packet, like hello packets do all kinds of stuff. So we're using this router advertisement to talk to the client and say, hey, you're going to do this or you're going to do that. Well, it's also where the device will package all the information into the advertisement. So it's going to package what the network portion of the IPv6 address is. It's going to package what the IPv6 default gateway address is. If there's a DNS server, it's going to package that in there. And basically, it will tell the device that you are going to randomly set up your own IPv6 address using the EUI64 process or a randomly generated IPv6 address. And we'll go into a little bit more detail. When can you think of a scenario that you might want to use SLAAC and not a DHCP server? Yes, exactly. You might not want to buy a separate device to do DHCP. You've got this perfectly great router that can do your DHCP for you. Yep, a very good, another reason, you just have a simple network. You don't really need to expand and use a DHCP. So cost is probably the primary reason. Now, the other thing is in Cisco, SLAAC is actually the preferred method for DHCP assignment. Okay, so you might be in a Cisco network, a Cisco shop, and they run it because it's the preferred method on a Cisco router. So let's talk about, now again, right now we're only talking about SLAAC, right? SLAAC is when the router does all of the work. It does all the work, okay? And you can see here there's a DHCP server on this network, but let's find out what happens even if there's a DHCP server on the network if I'm running a SLAAC. So the first thing I need to do is I need to enable my router for IPv6, right? So the command to do that is IPv6 unicast routing. Why do I need to do that? It more or less tells the router, like, hey, okay, we're going to be running an IPv6 network now. All the Cisco routers are capable of running IPv6. It's just that the unicast routing is not on by default until you activate and do IPv6 unicast routing, okay? So the first thing I'm going to do is I'm going to tell my router, hey, we're running IPv6, okay? So my client, my host device gets turned on, and it uses the all routers multicast address, FF02::2. Uses that address, and it sends out a message that says, hey, I'm soliciting for an IPv6 address. I need an address, right? It's like, I need an address, I need an address, I need an address. So the router is running SLAAC. So it's like, okay, well, we're running SLAAC. So here's everything you need. I'm sending the prefix length, the default gateway information, the DNS information. Here's everything that you need. And then end of story. This server that's sitting over here never even gets involved. Here's what it looks like. Here's my network, right? I'm not using the DHCP server, okay? I, as the network administrator, I've gone in and I've configured IPv6 unicast routing, okay? I've also told the router what its prefix length is, what the default gateway is, if there's a DNS server. So now this is the message. This information gets put into a router advertisement and it gets sent out to each of these devices. So notice they now know what their prefix is. They know what the ISP network address is. Then they'll use the EUI64 process to just generate their own address. And we'll, again, talk about that in a minute. So again, remember, they use the FF02::2. Hey, I need an address. I'm soliciting for an address, right? That's how the whole process gets started. Now there's a hybrid method, right? There's a blended version of this. And that is where I use SLAAC for IP address assignment. Okay, but I use a DHCP server to host other information. Now, this isn't uncommon, but I wouldn't say it's the most common, right? I mean, there's networks that do this, okay? And there's a couple of different reasons why. Again, Cisco routers, they work well with SLAAC, okay? But you may want to reserve your router CPU, its resources, and not use it to store a bunch of DNS information or gateway information or other information. So sometimes dividing and conquering is a little bit better. So you may want to use SLAAC to assign the IP addresses and use a DHCP server to store other information. So in this scenario, we're doing SLAAC plus DHCP. So I've got both set up on my network. So what happens, right, is I'm using both. So now the client starts sending solicitations. And it's like, hey, I need an address. I need an address. The router responds to it with an advertisement, and it tells it, well, you're going to get your address from me, the DHCP configured router. I'm going to provide that. Okay, which really means you're doing it yourself, okay, because of EUI 64, which I'll explain. But you're going to get the rest of the information from the actual DHCP server that is on this network. So what does the client do? It says, okay, thank you. I'll get my address from you. And now I will send out another message to the all DHCP servers, and I will get the rest of the information from the DHCP server. So since my Cisco router is doing address assignment, is my M flag on or is my M flag off? It's actually off, because when the M flag is on, the M flag only refers to the DHCP server doing the IP management. Yes, so Michael, that's a good clarifying question. So if you see, Michael asks, just to clarify, the only difference here is the storage location. Really, that's pretty much it, right? If I'm running SLAAC, the router is managing everything. It's managing the storage of the information. If I'm doing this hybrid where I'm doing SLAAC and DHCP, I'm splitting up the job, but the main job of address assignment stays with the router. Everything else goes to the DHCP server. So in this scenario,
Okay.
because the DHCP server is not managing the IP address, the M flag is off because it's not managing the IP address. Okay, now what about the other flag or other information? Is that on or off? Right, it's going to be on because other information is being stored on the DHCP server. So I'm telling the client, no, there's no DHCP server managing your IP address, but yes, the DHCP server is managing other information. When the hybrid method of both SLAAC and Stateful is being used, a router is used to assign the DHCPv6 addresses, and another server is used to deliver other information. The router uses the RA message to deliver this information to the client. So the router advertisement will deliver message to the client to use the EUI 64 process or random configuration for the IP address. The client will then also solicit a DHCP server to get other information, whatever the other information is. All right, so let's look at how this looks when we are using this blended hybrid version. So what do I first need to do on this router? Yeah, I need to tell it to use IPv6 routing, right? Enable, right, do the IPv6 unicast routing command. What happens next? My client is going to solicit for an address, so it uses the all IPv6 routers multicast address, FF02::2, to say, hey, I need an address. Now notice the router is going to respond with an advertisement, and it's more or less saying, hey, we're using SLAAC and DHCP here. So I'm going to give you the addressing information, but in order to get everything else, you need to go talk to a DHCP server. So now the client sends a second, so the client receives that message, right? And it's like, oh, okay, the router's going to help me out with my IP address, but I still need more information. So now this client sends out another message, and it's looking for any DHCP servers on the network. And it says, hey, are there any DHCP servers out there? I need some information. Well, this DHCP server will respond and say, oh, here's your DNS, here's your default gateway, here's your blah, 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 here's your information. Now the client has everything it needs. Now, it kind of seems like, gosh, that's ineffective doing all this. But IPv6 is actually so fast, right, that it doesn't slow anything down. And in this way, you can, again, kind of divide up your resources. It does add a little bit of, I don't know that security is the right word, but you know, you're not storing everything on one device if you had a failure or something. So there are some positives to doing that. Assurance, yeah. There's some positives and some reasons why some companies will do it this way. Okay. Now the other thing is it's not uncommon to have multiple DHCP servers. You know, that could happen for redundancy as well. And the DHCP server that will provide the information will be whichever one receives the request first. So if I had another DHCP server on this network with redundant information, whichever one got the request first would respond. But then if one of them failed, that information would be redundantly stored in another server, and it could just pick up where the one left off, right? I'm running a hybrid here. I'm running a little bit of SLAAC. I'm running a little bit of DHCP. So we talked about SLAAC only. We talked about SLAAC and DHCP. So when you're running DHCP only, they call that stateful. So we have stateless and we have stateful. Are there any questions about these two options? Yeah, so you can see here how now it's sending out its message. Right? Then we've got this last way of doing dynamic address assignment. So we have static, you assign it, SLAAC plus DHCP, and DHCP server only. Right? So in this scenario, now I obviously still have to have a router on my network because in order for me to route traffic through a remote network, I have to have a router. But in this scenario, we're straight up running a DHCP server. I'm not running any DHCP functions through my router. So in our lab, this is what we do. We have a straight up DHCP server. We've put all the information into the DHCP server. We do not use a Cisco router to assign IPv6 addresses when we do IPv6. Okay. Now you guys will do labs where you will take one of the routers and you will make it function like a DHCP6 server. But in our actual lab, we have a DHCP server, so DHCP only. Now this is more traditional, like an IPv4, right? You have a server, your computers come on, I need an address, right? Okay, so in this scenario, the client receives the message, they receive the advertisement telling it, oh, I'm going to get all of my address information from the DHCP server. So this is the time when the M flag is on, because when the M flag is on, that means that the DHCP server is managing address assignment. They all require the SLAAC and SLAAC plus stateful require a prefix. They really all require the prefix because even the DHCP server scenario, which is this scenario, I, as the network administrator, need to go into the server through the GUI and tell it or assign it what the prefix length is and what the network is. So here's the scenario where the M flag is on. Why is the M flag on?
Right here, because it's managing the addresses.
Yeah, because the DHCP is managing the addresses. And the O flag is off because there are no other devices that the client needs to solicit for information because the DHCP server is doing everything. So our M is on, our O is off. When stateful DHCP server only is being used, the router is only functioning as a router. No DHCP information is coming from the router. So the client will use the DHCP server for everything. The IPv6 address assignment, the server, gateway, whatever information it needs. The DHCP server is hosting all of it. So can everyone see why knowing that the router advertisement is managing all of this communication is super important? So in our option 3, what do we have to do with our router? So what do I need to tell my router if I'm going to be running IPv6? Yep, I want to turn on the unicast routing, right? So turn on unicast routing. Our host device does a solicitation. Now notice here, the router responds with an advertisement, and it's sending it to all IPv6 nodes, which is the same with the other scenarios too. Now, the all nodes means it's sending it to all the clients, which is FF02::1, right? And it says, hey, client, I don't have anything for you. I'm not managing the addresses. You need to seek out a DHCP server. You got to find a DHCP server to get you this information. So the client receives that notice, and it's like, okay, well, I didn't get the information from the router, so I guess I will send out another message looking for a DHCP server, which it does. It sends out a message to the all DHCP servers multicast address. It says, I need an address. The DHCP server responds with the information. Just a little review here. SLAAC is doing everything. The M flag is off. The O flag is off, right? And we're going to use the EUI64 process, which we're going to talk about here in a minute, okay? It's storing the DNS information, the default gateway. SLAAC is doing everything. The router has a big job. If I do stateless plus DHCPv6, that's basically stateless and stateful. I'm blending them. The management flag is still off because the DHCP server isn't managing the IP address, right? The router is. Now the client, since the router is managing the IP address, we still are going to use the EUI64 process to generate the IPv6 address. Or I can my device can randomly generate it. The DHCP server still has a job to do. It just doesn't have the main job. Okay, and then lastly, DHCP only. I've got a real life server. The server's doing all the work. So my RA flag, my management is on because it's managing the IP address and it's managing everything else. All right, so let's see how we do here. I am doing SLAAC only, right? What will my flags be for SLAAC only? Okay, so I need to know what the M flag would be and what the O flag would be. So if it's SLAAC only, that means what is doing the work? Who's doing the work when I'm doing SLAAC? The router. The router's doing everything. I don't have a DHCP server. So M is off because the DHCP server is not managing the address. Also, I don't need another device to hand out information because the router is doing everything. So both flags are off. Both flags are off because SLAAC, the router is doing everything. Okay, now what about stateless DHCP, where I'm running SLAAC and DHCP? What will my M flag be? Yeah, so my M flag is off because remember, the DHCP server is not managing the IP address, but because I have a server on my network that has a job to do, I do need to turn that on. And lastly, stateful DHCP. I'm just straight up running a DHCP server. My router is a router. My DHCP server is a DHCP server. Yeah, one, because the server is managing the IP address assignment. So yes, I don't need another device to do anything else because the server is doing everything. Questions about those flags? Because how do you tell your network what it's going to do? Well, you as the network administrator have to set configurations up in your device to turn those flags off or on so that the host knows. So what is the all nodes IPv6 multicast address? Like, what's the actual address and what does it do? Why do I use an all nodes IPv6 multicast address? Again, this is review from 140. Someone better look it up. It does have a 2 in it. Thank you, Sanook. Yes, FF02::1. Okay, now what is it for? What is it? Why do I use an FF02::1? It doesn't go to all the routers, but you're on the right track. Exactly, it goes to all of the nodes, okay? So the reason that IPv6 is a little bit more faster and is because it's more granular. Okay, so all devices get a special address called an all nodes IPv6 address. So if the router needs to communicate with PCs, like the hosts, it uses the all nodes multicast address. It doesn't use a broadcast. And that actually is more efficient and it's more secure than sending out broadcasts, okay? So the router will know which nodes or which host devices are attached to it, and it sends out a message to the all nodes multicast address. So my host has an all nodes multicast address, your host does, all the hosts do, okay? Now, what is the all routers multicast address? Yeah. FF02::2. So all of the routers in my network will have that IPv6 address associated. So if I, as the host, right, my host device needs to send a message to the routers, or another router needs to send a message to another router, multiple routers, it uses FF02::2 to communicate to the routers within its network, okay? So again, it's just a form of efficiency. It's more efficient than just broadcasting, right? Just sending everything out. Okay, what command enables IPv6 on the router? IPv6 unicast routing. Okay, you need to know those. Okay, you want to make sure you know all of these. These addresses are super important, and it will be very likely to see them on a CCNA exam. If I set up a stateless DHCPv6 router advertisement and DHCPv6, right? So if I'm doing the hybrid version, what are my flags going to be? If I'm using stateless DHCP, which is the hybrid, I'm using SLAAC plus DHCP version 6 server. What will my flags be? M is 0 and other is on. Right, exactly right. Because the router is managing the address, not the DHCP server, but I need the device to get its information from someplace else. So now PC1 is going to do a solicitation because it needs to find an address. What address does it use to solicit the routers? It uses the FF02::2, right? It sends out a multicast address looking, hey, is there anybody out there? I need an address. I need an IPv6 address, right? So it sends out a request. It's like, please, I'm soliciting for a router advertisement. I need a router to give me an address or tell me what to do. I'm lost here without an address. And it uses FF02::2. All right, let's do a matching here. So who can take SLAAC only? Where does it match up over here for SLAAC only? For, let's see, the device gets the prefix length, and default gateway address information contained in the RA message. Yeah, that sounds right to me. It gets everything from the RA message, right? Everything. Okay, now what about stateless, where I'm running SLAAC and DH? Let's see, the device gets the prefix length in the RA and obtains other available information from the server. That looks right to me. And how about DHCPv6 only? So it's running a server. Hi, David.
Sorry, the first one?
Yeah, the first one. And then this one right here is manual addressing. So I think, Adrian, what you were probably thinking of is as a network administrator, plugging that information into the router. But notice here, it says through the control panel. So that means I'm right in front of my computer, I pull up the control panel, and I manually assign it. So you have to read those questions carefully so they don't mess you up, because I know you know which one, but I think the control panel is that key there. Okay, so what is the process called used by SLAAC and stateless DHCP to generate a unique IP address? EUI64. Exactly. EUI64. So we know that if we're running SLAAC or stateless, the router is managing the IP address assignment, right? Well, here's the next reason why SLAAC is efficient, okay? The reason is because if you're running SLAAC or the stateless DHCP, it kind of passes the work on to the client, okay? So it sends it a router advertisement and it says, okay, well, we're running SLAAC here. I'm in charge of the address. Here's the prefix length, which remember is the network portion as well as the subnet ID. And you, the client, your client device, you need to figure out your unique portion, the unique portion of your address. Because remember, for all of us on the same network, so again, think about our classroom. If we're in the classroom and we're all in class and we pull up our control panel, we will all have a different IPv6 address, but the first 64 bits will be exactly the same because we're on the same network. But each host device has to have its own unique last 64 bits, right? So all the EUI64 process means is that we take the MAC address. So let's see, I'm going to pull up my command prompt here so that we can, oh, I already have it up. Can everybody see this? So right here is my MAC address. See that? 0C54850C1B E9. And can we all agree that everybody has a MAC address on their computer? Everybody. Can we also agree that the world according to computers is that everybody's MAC address has to be different? It's unique. There's no two that are the same. So what my MAC address is will be totally different than your MAC address. Can we all agree that that's the case? What the EUI64 process does is the SLAAC router will send the client the prefix length, the ISP portion. And then it says, and client, you need to make up your own unique part of the 128 bits. So what the client does is it goes and it looks at its MAC address, okay? Then it divides its MAC address in half and it inserts a couple of nibbles in the middle. It inserts an FFFE in the middle. So here is my MAC address, right? It gets split in half and then it inserts the FFFE right there in the middle. So here it would be I'll do it a different way. It inserts this FFFE right here in the middle, okay? Now, if you notice, once I've inserted it, now I have 64 bits. This is the unique portion of my IPv6 address. The first 64 bits are my network. The last 64 bits are my IP address, the IPv6 portion that's unique, so that every one of us have something different. It's all bitted out, and then it just puts it all back together. That's what an EUI64 process is. I promise you will be challenged on the EUI64 process on the CCNA exam. You might not need to know exactly how to do it, although I recommend you know how to do it, but you'll have to recognize something. So if you were to see an IPv6 address that looked like this, how many do I have? 1, 2, 3. Okay. What could you tell about that address? What would you be able to know just by looking at that address as it relates to DHCP? So on an exam, you see that IPv6 address, and they say, how was this IPv6 address generated? Yes, Chris, exactly right. Look here, everybody. It has FFFE in the middle. Okay, it has FFFE in the middle, right there. So because it has FFFE in the middle, I know that SLAAC is turned on, because otherwise it wouldn't have FFFE in the middle. Does everybody understand that? See this? Got FFFE in the middle. So remember what EUI64 does. Yes, 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 yes. Does that color not show up right and it's dark enough? Does everybody understand what I just did? If not, well, because you're going to have to do this in a minute. So this makes SLAAC and stateless DHCP very efficient, because it pushes a little bit of the work out onto the NIC card of the client. The NIC card goes and looks at its MAC address, it splits it, and it adds it to the end of the 64 bits of the network, and now it has its own IPv6 address, okay? Now, another way that it might have EUI turned off. If the client receives a message from SLAAC router saying, hey, you know, we're figuring out our own IPv6 addresses here, you go ahead and do it. Sometimes EUI64 is turned off. If it's turned off, then the NIC card on the PC just randomly generates 64 bits. It just randomly generates 64 bits. Why might I turn EUI64 off? Why would I maybe turn that off? Yeah, it's not that it's easier to figure out. EUI is actually easier to figure out. It's a security problem, right? Because if you have someone that's smart enough and they look at your IPv6 address and they see FFFE in the last 64 bits, 24 bits in, they can reverse engineer your MAC address, and then they could do MAC address spoofing, right? So it's a security problem, okay? We happen to turn it off on our campus. We don't run EUI64. Now, I've turned it on some of our devices so that we can see it, but we actually leave it turned off. Step one is you divide the MAC address in half, right? Then you insert FFFE. Then you convert everything to binary and you figure out what your address is. Now, there's one final step in the EUI64 process, okay? You have to convert the 7th bit. So you flip bit 7. So after you split it and you add FFFE, you count over 7 bits. 1, 2, 3, 4, 5, 6, 7. If the bit is off, you flip it on. If the bit is on, you flip it off. So you flip your bits off and on. The 7th bit only. So again, you divide, add FFFE, flip your 7th bit, then you put it all together, and now you have your IPv6 address. Okay, so we're going to do one right now. Everyone should have a piece of paper out. So notice here, my RA message tells me that the managed flag is off and the other flag is off. So I know that SLAAC is running. So SLAAC is going to send a router advertisement down to the PC saying, hey, here is our prefix length, which is the network. Go ahead and figure out your IP address, okay? So here's the MAC address. So everyone take 5 minutes and figure out what your IPv6 128-bit address would be. So you know the first part, right? First part's easy because it's in the router advertisement. There's the first part. Now you need to figure out the next group of hex text. Right? You need to figure out this hex text, this hex text, this hex text, this hex text, using the EUI64 process. Okay, so step 1, you divide the MAC address in half, right? And you insert the FFFE in it, and then you flip the 7th bit. You would split the 22222 in half, right? You split that in half. So you've got the network portion of it because they gave us that, right? The router gives us that. So we're going to split the MAC address in half and add the FFFE in there. So that's where we're at. Then you have to flip the 7th bit, right? So here's our 7th bit. We know that each of these nibbles has 4 bits in them. So how would I write out 2? I would write it like this, right? There's 2, so right here. Then I would write out 2 again. Now I flip the 7th bit. There's 4, 1, 2, 3, 4, 5, 6, 7. So since the bit is on, I have to turn it off, right? Since the bit's on, I have to turn it off. And turning it off is what gives me the 0. Okay. Okay, so now we know how SLAAC functions, right? SLAAC says, hey, I'm going to handle everything. I've got the prefix length. I've got the DNS server. You're going to use the EUI64 process and figure out your own IPv6 address, right? So it does all that. So how does a host device verify that the address it gets or it's made for itself is really unique? How does it do that? DAD, exactly right. It uses a protocol called DAD, duplicate address detection, okay? So once the device, this device over here has come up with its address, it's got an IPv6 address, and it doesn't really matter how it got that address, whether it was through SLAAC, stateless, stateful, any type, even when you statically assign it, what happens is that device sends out a message. Now notice here, right, it's using the solicited node, so anyone on its network, and it's like, hey, this is the IPv6 address that I'm going to be using. Is that okay? Does anybody else have that address? Yep, it uses neighbor solicitation and neighbor advertisements. right? Because it's sending it to its neighbor. And then the neighbors respond. Or actually, they just look at it. They don't respond. They look at it. As long as it doesn't match, they just drop the packet. Now, if it matches, then they respond. And they're like, whoa, 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 I'm using that address. If that's the case, the client starts all over to get a new one. But no matter what type of service or method of DHCP that we're using, we're always going to do DAD. So we know that we've got these 3 different methods, plus we have regular static assignment. No matter what, we use DAD. Okay, so let's come back at 8 o'clock, take a break, come back at 8 o'clock. We're going to finish this module, and then we're going to do an EUI 64 assignment. Go through these, all right? So again, we know that the router advertisement is king, right? It does all this work. It sends all these messages. Okay, so who can take this first one? The client sends a DHCP version 6 what message to the reserved multicast all DHCP version 6 server address? Martin, you've got an RS. Can you tell me what an RS is? Solicitation, right? Again, how many times when we were talking, remember I always said the client solicits for an address. It's soliciting for an address. So in IPv4 speak, right, what is the DHCP IPv4 message type? Because I want you to compare and contrast and see how they're a little different. So it's called a solicitation for IPv6. What is it on IPv4? A discovery, right? It's a DHCP discover. So with IPv6, they need to buy something. They're trying to buy an address. IPv4, they're trying to discover an address. Okay. How about the next one? The server responds with a DHCPv6 blank message informing the client that the server is available for DHCP services. Okay. So it responds with an advertisement. So it's like, hey, I need to buy something. I need to get myself I need to solicit for an address. Well, the server has one that it's advertising, doing an advertisement. So remember, the routers and the servers are using advertisements. They're using advertisements. Okay, so the client responds to the server, right? So it's responding back to this advertisement with what kind of a message? So it's a particular type of request, Michael. So if you kind of think in terms of IPv4, it's similar. So it's like I need to solicit. Okay, I'm soliciting for an address. The server says I have one to advertise. So now the client's received it, and it does an information request. Okay, so again, the client sees what the server's advertising, and it's like, okay, yeah, I'll request that. And they call it an information request, because it doesn't actually take the address yet. It does an information request. Okay. And then with a DHCPv6 blank message, this is for a stateful client, to obtain an IPv6 address and all other configuration parameters from the server. This is the straight up request. So that's why there's a little bit of this variation, right? Because with stateless, right, we're going to use the EUI 64 process. So that's why it's called an information request versus a straight up request. That's the only variation. Do I think that you will be challenged to know the difference? Probably not, hopefully not. Okay. And then what about number 4? The server sends a DHCP blank to the client containing the information requested. So they've done this back and forth. I need to solicit for an address. I have one to advertise. Oh, that's great. I'd like to request what you're advertising. And the server responds with a An IID. I don't know what an IID is. Well, the server is actually, I don't know if it's unicast. It might be a multicast, but that's not what this is asking for. Like, is it a solicit, an advertise, a request? A reply. Okay, so in DHCPv6 speak, that's similar to what in DHCP version 4? A reply is similar to a what? Yeah, an acknowledgement. Okay, so it's the same process. They just have to call it something different because it's IPv6. Okay, I need to solicit for an address. I have one to advertise. That's great. I'd like to request it. Okay, I'm acknowledging or I'm giving you a reply. I'm responding with a reply. It is kind of annoying. I agree. Why can't they just call it the same thing instead of, you know, like they could call it version 6 offer, a version 4 offer. It would be so much easier, right? Hey, again, just here's a pretty picture. Right, here we're doing our solicitation to the FF02::2. The router is responding with an advertisement. There is a multicast address for the all DHCP servers. I want to say it's FF02::6. Would somebody look that up? Do a Google search for what is the multicast address for DHCP servers, Mama Queens. So what is the multicast address for DHCP servers? I don't remember it off the top of my head here.